Alright, let's take the first question. Question 1. Under quantitative, or we'll call it volumetric analysis. So the question is a practical question, but we will take it as alternative practical, meaning we are not doing a real experiment. And the question goes thus: A is a solution containing 5 grams, the mass is 5 grams, of HNO3 in 500 cm3 of solution. So it means the acid is HNO3. The next info: B is a solution of sodium hydroxide of unknown concentration. No information is given. Now, A, instruction, you are told put A inside burette. Burette is that long tube, that long narrow tube. So we are told to put A inside the burette and titrate it with 20 cm3 or 25 cm3 of B. So in order to measure the volume of what? B, we use what called pipette. And pipette, the volume of a pipette is either 20 or 25. So which is going to be the volume of the base. Let me call it VB. So for the purpose of this question, let's assume we are using 25 for the volume of what? The base. Using methyl orange as indicator. We've already explained that. So that indicator is to change color to show us the end point after adding the acid. We are told to repeat the value, concordant theta values, meaning you repeat like 2-3 times. Tabulate your reading, calculate the average volume of acid used. You follow this instruction fully if it were to be a real practical. But in this case, it is alternative practical. So if it's alternative to practical, you should be given the what? The average volume of acid used, which is what? Given here. That's V. So the essence of the first part is to know the volume of acid that will neutralize 25 cm3 of that base, which in this case is given to be 24.75 cm3. The B part. From your results, calculate concentration of A in mole per dm3. That's molar concentration of A. And what is it? Recall during the lecture, molar concentration equals what? Mass concentration over molar mass. And we can easily get the mass concentration because the mass concentration is the mass over volume. So in this case, the mass concentration equals to, what's the mass? 5 grams. What's the volume? 500 cm3. But the volume must be in dm3. So we have to divide this 500 by 1000 to give us what? 0.5 dm3. So it means the volume of A rather, has given is what? 0.5 dm3. And from here it means the mass concentration is what? 5 over 0.5 should give us 10 gram per dm3. So this is what called mass concentration or concentration in gram per dm3. But what are you looking for? Molar concentration, which is concentration in mole per dm3. To get this molar concentration, we need to know the mass concentration and the molar mass. Already we know the mass concentration. Now let's get the molar mass for HNO3. So for triazole nitrate 5 acid, the molar mass equals to hydrogen is 1, nitrogen is 14, and oxygen is what? 16. That's 16 times 3. From here, we will get the molar mass of HNO3 to be 63 gram per mole. So what is now the molar concentration? That's mass concentration, which is 10 gram per dm3 over molar mass, 63 gram per mole. Then from here, what you are looking for, which is the molar concentration, is going to be 0.16 mole per dm3. That's I. Concentration of B in mole per dm3. Now, from the question, we are not given information. So what are you going to do? Now, we now have to write the balance equation. What is the balance equation of the reaction? So we are having the acid HNO3 with the base NaOH to give us the salt is going to be this with this. That's NaNO3 plus H2O. And I think the equation is balanced. Now, from this balanced equation, it means the number of mole of acid and base are 1:1. So it means Na is 1, Nb is 1. And already, this Cm, it is what? Concentration of A, move by without Ca. Our Ca is Cm, which is 0.16. Then we want to get Cb, concentration of without Cb. To get Cb, record the formula CaVa over Cb Vb equals to Na over Nb. So we are looking for Cb. From here, you make the subject Cb equals to Nb CaVa over Na Vb. You make Cb the subject. So now let's now impute the values. What is Nb? 1. What is Ca? 0.16. What is Va? This is Va is 24.75. What is Na? Na is 1. Vb 25. So from here, the concentration of B in mole per dm cube will be, so we are going to get 0.20 mole per dm cube. But this time around, we decided to use 20 instead of 25 because the question says 20 or 25. For some reason, our practice use 20. So that will be the concentration of B. So this Ca, Cb. Ca is same as what? This is what? Cm. The molar concentration of A. Now next part. The concentration of B in gram per dm cube. That's I. The concentration of B in gram per dm cube. We recall the same formula from here. It means concentration in gram per dm cube equals to concentration in mole per dm cube times molar mass. We already know that's for B. For B now, we know the concentration in mole per dm cube. That's 0.2. Now I need to know what? Big N for NaOH. In this case, the molar mass becomes sodium is 23, oxygen is 16, hydrogen is 1. From here, we are going to get the molar mass of sodium hydroxide to be 40 grams per mole. So, the mass concentration of B equals to its molar concentration 0.2 times the molar mass, which is what? 40. So Cb is 8 gram per dm cube. Then IV. Calculate the mass. There should be D here. Calculate the mass of sodium nitrate formed if 250 cm cube of sodium hydroxide were neutralized. So meaning instead of neutralizing 25 cm cube, if 250 cm is neutralized, what will be the mass of sodium nitrate that will be formed? This question is under stoichiometry. This time around, we are actually comparing this salt with this base. This salt here with this base. And what do we actually need from the equation? It is their what? Mole. From here, it's obvious. 1 mole of this gives 1 mole of this. So since they have the same mole, number of mole in the reaction, so it means the mole of sodium hydroxide here must be equal to the mole of what? Sodium nitrate. Let me re-explain. According to the answer we have in here, this Cb, or let me say this one, Cb. Note, they are both Cb. But this Cb is what? In mole per dm cube. This Cb is what? Gram per dm cube. So this one is mass concentration. This one is what? molar for mole concentration or molar concentration. So the unit differs them. So this concentration of B in gram per dm cube, concentration of B in mole per dm cube. Now, normally the concentration is what? 0.2 in mole per dm cube. But if 250 cm cube of sodium hydroxide will neutralize, what will be it? So in this particular analysis, you have to get the number of mole of sodium chloride here, or sodium hydroxide rather. If you are given the volume of a particular solution, we can look for is what? Number of mole. Why? Number of mole equals to concentration times volume. And in last class I explained that CV. And this C must be what? Molar concentration. That's mole per dm cube. This one must be what? In dm cube. So let's put number of mole here. So number of mole of NaOH in this case equals to its concentration in what? Mole per dm cube. But do we know it? Yes, we know it. What was it? 0.2. Over its volume. Do you know its volume? Yes, we are doing this one 250. But it must be in dm cube. So when we go by 250, we must divide by 1000 so that it will be in dm cube. So in this case, number of mole of NaOH when the volume is down to 50 is going to be 0.05 mole of sodium hydroxide. What was the question? We want to look for the mass of what? Sodium nitrate formed. But why do you need to go to get mole of what? Sodium hydroxide? Because in the question, you are comparing this salt with this what? Base, or with this alkaline. So that is why we need to use this information. That is why we need to use information to get the amount of mole. Now, what's not the essence of this equation? This is telling us that this base with this salt, their mole ratio is 1:1. So if use 1 mole of this, if 1 mole of this one react to this, you only see 1 mole of this. If 2 mole of this react to this, you form 2 mole of this. So they are 1, 1, 2, 2, 0, 0. Now, since in this question now, the number of mole of sodium hydroxide is 0.05, so it also implies that what? Number of mole of sodium nitrate is also what? 0.04. Why? From here. I think we have what? 1:2. So we are going to say, if 1 mole of this one gives 2 mole of this, 0.05 mole of this will not give X. Then look for X. But in this case, they are equal, so it's the same. So now, what are you looking for? Mass. Because the first formula I gave you last class is that what? Mole equals to mass over molar mass. Then the mass you are looking for, M equals to mole times molar mass. So what's the mole here? 0.05. So we need to get the molar mass of sodium nitrate. So for sodium nitrate now, NaNO3, its molar mass equals to sodium 23, nitrogen 14, oxygen 60 times 3, that is 48. From there, we'll get the molar mass of sodium nitrate to be 85 gram per mole. Now, we are looking for the mass M. The mass M equals to number of mole 0.05, molar mass 85. So therefore, the mass you are looking for M equals to 4.2 gram of sodium nitrate. That is the end of the question. And this is one of the direct questions can be asked. Very direct. Now, consider the second question. A is a dilute tetraaldosulfate 6 acid, that's H2SO4. B contains, so this is A. For B now contains 1.5 gram, that is mass, 1.5 grams of sodium hydroxide per the volume 250 cm cube for sodium hydroxide. In short, we are given a mass concentration indirectly. If 25 cm cube of B, that was one of B, 25 cm cube of B is requires requires 50.5 cm3 of A. So it means the volume of A, that is the titer value, is 15.5 cm3 of A for complete neutralization. Calculate 1. The concentration of B in mole per dm cube. Once you get B in mole per dm cube, that's the molar concentration. First, let us write a balanced chemical equation for the reaction. So what are you going to get here? So sodium with sulfate, Na2SO4 plus H2O, not balanced, so let's put 2 here, and I think with that everything should be balanced. Is that it? Water is 4 here, so there will be 2 here also, balanced. So it means Na is 1, Nb is 2. Now if you see, you call the formula that Ca Va over Cb Vb equals to Na over Nb. We are looking for Cb. Do we have Ca in mole per dm cube? So from the question, you are not given. Since you are not given, we can only use formula. Let's see if there is other parameter given. Okay, from here, this for B, we can get the concentration of B in what? In gram per dm cube. So let's get concentration of B in gram per dm cube. That is what? Mass concentration, which goes to the mass over volume. Mass over volume. So it means the concentration in gram per dm cube equals, so what's the mass here? 1.5. The volume must be in dm cube. So that will be 250 over 100, 0.25. And that will give us 6 gram per dm cube. But that's not what we actually want is what? The concentration of B in mole per dm cube. That's molar concentration, which goes to what? The conc in gram per dm cube over molar mass. So for B now, what's the molar mass of B? We are told that B is what? Sodium hydroxide. And from our previous question, we got the answer to be 40 grams per mole. This time around, Cb, which is what? Concentration in what? Mole per dm cube equals to 66 over 40. Then Cb, which is the concentration of B in mole per dm cube, will give us 0.15 mole per dm cube. Second part of the question, II. The concentration of A in mole per dm cube. So that's A. Now from here, we are now using this formula. Please, it is very important you write the formula out. For theory, if the formula is not written, you lose mark. From here, if you make Ca the subject, or the best, let's include the values there. We are looking for Ca times, what's Va? Va is equal to 15.5, the theta value, over Cb, because it's equal to 0.15. Then Vb as 25 equals to Na from here. Na, that's acid 1. Nb, that's 2. From here, if you make Ca the subject, Ca becomes 0.15 times 25 times 1, everything like this, divided by 50.5 times 2. From there, we get the concentration of the acid to be 0.12 mole per dm cube. Then the third part, the number of hydrogen ions in 1 dm cube of solution A. Number. Anytime we are trying to get the number of particles, we have number of ions, number of atoms, anything number, we should recall that mole equals to number of particles. In this case, number of ions over Avogadro's number 6.02 times 10^23. So in this case, it means the number of hydrogen ion equals to this times this number of mole. Sorry, number of hydrogen ion now. Number of ions equals to number of mole times 6.02 times 10^23. So we only need to know the number of mole of hydrogen ion for the question. So what was now the mole of hydrogen ion? So that hydrogen ion will be gotten from this compound, H2SO4. So we know if H2SO4 dissociates, we are going to get H plus and SO4 2 minus. For every 1 mole of this, we have to balance the equation, so 2 has to be here. 2H and SO4 is 1. So meaning for every 1 mole of what? This acid, we get 2 moles of what? H plus. That's the meaning of this. So for every 1 mole of this, we get what? 2 mole of H plus. But the question is, what is now the concentration of A itself in the question? Ca. Ca is 0.12. So when the mole of this acid is 0.12, what number of mole here? That's N. N times 1 is N. 2 times this will give us what? 0.24 moles. So it means that is what? Number of mole. And this question I've made easy. Why? The number of hydrogen ions in 1 dm cube of solution of A. And we've been dealing with 1 dm cube since. We've been doing that's per dm cube, 1 per dm cube, 1 dm cube. And then we are told per 2 dm cube. So we have to still do some manipulations there. So here we know number of moles already, so we can look for number of ions. So therefore it means number of hydrogen ions equals to N times this, and what's N? 0.24 times Avogadro constant 6.02 times 10 to the power 23, and from here we get the final answer to be 1.44 times 10 to the power 23 hydrogen ions. Well, to get more accurate results, sometimes it is necessary to leave our answer in 3 decimal places. But in this case, I maintain 2. So perhaps for our next question, we are going to use 3 decimal places for our calculated value. Now, the third question. A is 0.05 mole per dm cube of H2SO4. So it means the concentration of A, Ca, is 0.05 molar or mole per dm cube. And B is sodium carbonate. So for the equation, we are going to be having H2SO4 plus sodium carbonate, and we are going to be having sodium sulfate, then H2CO3, which will decompose to both H2O and CO2. I've explained this in last class or in our previous lessons that anytime we have this acid H2CO3, it decomposes to give us what? Water and CO2. And it's a weak acid which ionizes partially. Now, I think it's balanced, so that's 1:1. Na is 1, Nb is 1. Let's continue the solution. If 3.7 cm cube of A, meaning Va, is 37.5 cm cube, was required to neutralize, that's Bb, 25 cm cube of B, that's Bb. Calculate I concentration of B, I like for Cb. Very simple, CAVA over CB, VB equals to NA over NB. From here, what is CA? CA is going to be 0.05. VA is 37.5 divided by CB. What is CB? That is what we are looking for. Then VB, 25. NA, correction there is 1. NB is also 1. From here, if you can multiply, you get CB to be equals to 1 times 0.05 times 37.5 divided by 25 times 1. So it means the value of CB is going to be 0.05 mole per 0.075 mole per dm cube. The second part, the concentration of B in gram per dm cube. Concentration in mole per dm cube equals to concentration in gram per dm cube over molar mass. So Cg equals to Cm times M. And Cm is what? 0.075. We need to look for the molar mass of B. And what is B? B is washing soda. So for Na to CO3, its molar mass equals to, we have 2 sodium, and sodium is 23. We have 1 carbon, which is 12. We have 3 oxygen, which is what, 16. At the end of the day, we get the molar mass of washing soda or sodium tricarbonate 5 to be, sorry, carbonate 4 to be 106 gram per mole. Then from there we can easily get what? The concentration in gram per dm cube What is cm? Cm is 0.075 times the molar mass m, 106. So it means the concentration of B in gram per dm cube will now be 7.95 gram per dm cube. Then last part of the question, volume of CO2 liberated at STP. Note, I gave you at the beginning of this class or the end of last class that the volume of any gas at STP equals to what? Sorry, the number of mole of any gas equals to what? The volume of that gas over 22.4. That's at STP. At STP, this always what? Holds. So in this question, we want to get the volume. From here, it means the volume of the gas equals to number of mole times 22.4. Once you know the number of mole, you can get the volume. And the one will be in the MQ. So let's not get the number of mole. What was the number of mole in this case? Volume of CO2 level at STP. So when you check CO2 here, they are all in ratio 1:1. Now, it is best we compare CO2 with sodium carbonate. Why? It is because it is from what? The composition of this one, from the composition of this, we have what? CO2. But it doesn't really matter. We can even compare this with this. But what is most important is you compare one thing to another, what you have information about. And here, let's compare this with this. First, they are 1:1. So it means 1 mole of sodium carbonate give 1 mole of what? CO2. Note our aim is to know mole of CO2. So now first, in this question, what is the exact mole of what? This is like general mole. If one of this is acting with one of this, you get one of this. But in this particular equation, number of mole is not necessarily 1. So what will not be one number of mole of this one here actually? So number of mole of sodium carbonate. We know its molar mass. Do we know its mass? The mass of sodium carbonate is given. Okay, from here. Since we are not given the mass, so we cannot use this one to determine it. So what can we use? Recall. Now our focus is now on washing soda. Recall that since we know its concentration, number of mole equals concentration times volume. So what's the concentration of sodium hydroxide? Sorry, sodium carbonate here? 0.075, 0.075. And what's the volume? The volume used is where is it? Volume of that's 25 cm3. And as I told you, it has to be in dm3 over 1000. So from there, the number of mole of sodium carbonate in this situation is 0.001875 mole. Now note, back here, if 1 mole of this give 1 mole of this, it means 0.00187 mole of this will also give same mole of it. So it means the number of mole of CO2 now, number of mole of CO2 is also equals to what we have here. So our aim is to get the volume. So this time the volume becomes number of mole 0.001875 times molar volume 22.4. So the number of mole in dm cube, sorry, the volume of CO2 in dm cube now becomes 0.042 dm cube. In case you want to answer to be in cm cube, multiply by 1000. 1, 2, 3. That is what? 42 cm cube. And that is the answer. When you note very well, you see, this is an acid obviously. But this one doesn't look like this. Actually, it's a salt. But recall, during last class I explained that these salts will have an it is going to show alkalinity, meaning it will have a pH greater than 7. Why? Because it is formed from weak acid and a strong base. How do you know it's formed from weak acid? This CO3 pair with hydrogen, that will give us H2CO3. This Na pair with OH, that will be NaOH. This a strong base, this is a weak acid. So at the end of the day, we are going to get what? A basic salt, or a salt that will be alkaline in nature. That is why this salt is acting as a base in this case, because it has a pH greater than 7. So I think we can stop with these 3 questions. Then in our next classes, we'll solve more questions. Some that will lead to purity, some will lead to the one that has water of crystallization and the likes. So we're dealing with hydrated salt and hydrous salt. But for now, I think we can end everything on titration here or neutralization here. And we've done a part of quantitative or volumetric analysis. See you in my next class.